Assalamualaikum warahmatullahi wabarakatuh. Today I would like to present you a paper entitled Fiber Optic Test Bed for Fiber Optic Cabling and Testing. And my name is Muhammad Nawar bin Saleh and I am from Polytechnic Muazzam Shah, Pahang. For the intro, the project stems from the need to provide a fiber optic test bed for fiber optic loss testing in the labs and low cost design by using passive devices component for student training. The idea of combining three components of the experiment which are installation, testing and commissioning that will enable students to understand the key elements in the fiber optic communication cabling in the real environment. The laboratory exercises module will be based on the system design which allow the student to test passive devices behavior, losses, splicing techniques, OTDR, and mathematical calculation towards the fiber optic power budget in fiber optic communication. For the problem statement, number one is for the time being, there is no dedicated test bed for the fiber optic for the student in Polytechnic Muka. Number two is lack of the real environment passive optical network, which is found, test bed in laboratory exercises, and number three is available equipment in the market is very expensive. The objective of the project are to design a proof of concept prototype test bed for fiber optic cabling and testing. Number two is to implement the real environment passive optical network test bed for the training purposes, and number three is to design a low cost test bed for training purpose. Methodology used in this project adapt from the SDLC, which is System Development Life Cycle. We have a five phase, and the first phase include the info gathering, design requirement, objective of the project, and scope of project. The number two phase, which is analysis, include the case study and user requirement. In the design phase, there is include the development of cabling architecture, design topology, integrated fiber optics network cabling topology, and number four, which is implementation, there is include setup design in the real environment and the try run. And then lastly, number five, maintenance, which is include the update cabling, fix broken piping, monitor cable break, and connectorization. As you can see in the slide, this is a test bed design and setup. The figure 1 shows the testing FOTB testing design setup, which is there are three passive devices, isolator, coupler, and circulator. And figure 2 shows the station setup architecture for each passive devices. So station 1 is insulator, isolator, station 2 is coupler, station 3 is circulator, and station 4 is combination of the other three earlier passive devices. This is a full setup of FOTB station with the passive device and fiber optic cable. Figure 4, process of configuring each station with the passive device and fiber optic cable. Figure 5 is complete setup of FOTB test bed for outdoor use. Figure 6 is proposed FOTB implementation site. So let me share with you a video, a process of designing, testing, commissioning the FOTB. The testing has begun in two conditions, which is indoor and outdoor. For the outdoor, students need to the experiment by using laboratory test the design core and use all the station to get the result. So the student will have an experience how they terminate the fiber outdoor. So this question, the original idea of this test bed was intended to as a teaching aid to a lecturer who taught the subject of DEP 5313 fiber optic application. The lack of the teaching aids made it difficult to the student to understand application related to the theories as well as the practical exercises that cannot be done perfectly according to the syllabus. Through this test bed, students will be able to understand the operation of fiber optic networks and the characteristic of passive devices. The losses and power budget in fiber optic also can be determined through the exercise. There are some major challenges faced during this project, which is a limited budget, difficulty in getting fiber optic devices, and delay of the item delivery. For the feature enhancement and conclusion, for the feature enhancement, the test bed will be upgraded in terms of adding more functions, such as for OTDR testing. Use harder PVC pipe and resistant to prevent rain or sand entry and heat resistant as the setup is located at the outdoor. Build a proper test bed with a roof on the project area to prevent students or lecturers exposed to hazard or even hot weather when splicing and calculating the total loss of fiber optics. So the conclusion is fiber optic test bed has been successfully developed as a proof of concept lab prototype. One may argue that the setup bit does not represent a total solution system. However, the system can give a new idea to develop further towards a comprehensive solution. Okay, that's all from me. Thank you.